Alright, your homework for lesson 11.4 is to write down the notes from this video that you're about to watch. So make sure, for homework, you take notes on this video. Okay, if you come across a point in this video that you are not sure, what you should do is stop the video, circle the part that you're not sure about, and then write down your question. Okay? So that when you get to school on Monday and I say, are there any questions on these notes? You can say, okay, hey, Mr. Otto, I got a question, and I circled exactly where it was. Here's my question. It says, why did the chicken cross the road? And then I'm going to go, well, if you notice from the work that we did, the chicken crossed the road because there was food on the other side and he was hungry, based on the notes that we had. Obviously, we're not talking about chicken crossing roads. We're talking about math, but you get the point. I can at least answer your question based on what you have there. I would recommend writing your question in a different color so that you can kind of understand what's going on also, or so that you can find your question easier. So, homework, take notes. If you have a question on something, circle it, write the question down in a different color, and when I ask for questions on Monday, you can ask what that question is. So, enjoy the lesson. Alright, so today's lesson is on 11.4, and there is a rational roots theorem. Alright, so the rational root theorem states that we're going to let p of x equal a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus plus a sub 1 times x plus a sub naught. So that notation is just stating some generic polynomial function where the a sub n minus 1, and so on down to a sub 1 and a sub 0 are the coefficients, and x to the n minus 1, and so on down to x are the variables to some power. And if you notice, we're stating that all those coefficients, a sub n minus 1, all the way down to a sub 1 and a sub 0, are integers. So we have rational coefficients, which means that we know that conjugates are also going to be roots from our other theorem. Okay? So the important part of this is, of the rational roots theorem, is that we consider a rational number c over d, where c and d are relatively prime. That means that c over d is a reduced fraction. For c over d to be a root of p of x, c must be a factor of a sub 0, the constant, so that would be c must be a factor of this number right here, the last term, and d must be a factor of a sub n, the first term. Okay, which is the leading coefficient. I wrote factor, and it probably should say leading coefficient. So let's fix that real quick. All right. So you see, a sub n is the leading coefficient. So what this means is we take our first example. Example 1. Okay. Example 1 states that we're going to let p of x equal 3x to the 4th power minus 11x cubed plus 10x minus 4. Okay, so here a sub n, which is the leading coefficient, is going to be 3. Let me get that from right there. Okay, and then a sub 0 is going to be negative 4, which we get from right here. Okay, so that means that C must be a factor of -4. And D must be a factor of 3. And that C over D must be a reduced fraction. We say that because C and D are relatively prime. So for two numbers to be relatively prime, if we made them a fraction, it would be in reduced form. Okay, so let's look at C, the possible numbers for C and the possible numbers for D. Okay, so the factors of -4 are 1, -1, 2 and -2, and 4 and -4. Okay, because 1 times -4 is -4, -1 times 4 is -4, and 2 times -2 is -4. Factors of 3 are 1 and -1, -3, 1, and +3. Okay, so now that leads me to what are my possible choices for roots. Well, I could have C over D. So 1 over -1 is -1. 1 over -3 is -3. 1 over 1 is 1. And 1 over... oh, snap. Okay, so my possible roots here are... I'm going to take all of this and I do 1 over -1, 1 over -3, 1 over 1, 1 over 3. And I write those down for C over D. So 1 over -1 is -1. 1 over -3 is -1/3. 1 over 1 is just +1. 1 over 3 is 1/3. Well, if I did -1 over -1, I have 1, which is already there. -1 over -3 is +1/3, so I've already used the -1 because I've got all of those possibilities there. So then I look at 2. So that's 2 over -1 is -2. 2 over -3 is -2/3. 2 over 1 is 2. And 2 over 3 is +2/3. Okay, if I use -2, I would end up with those exact same values. So then I go to 4. So that's going to be 4, -4/3. Oh, sorry, -4, -4/3, 4, and +4/3. And if I used -4, I would end up with those. So if you look right here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible numbers to choose from. Okay, so what we're going to do is we have to determine if they are roots. To determine if they are roots, we get to use synthetic division to test that, or we could also just plug in each one and see if it gives you p of x equal to 0, which is what I suggest doing. So to test these roots to see which ones work, my suggestion is we're going to test using the calculator. Okay, so I'm going to plug all of these into my original p of x up here to see which ones equal 0. So if we plug in those values right here, if p of x equals 0, then we know, then we have a root. Okay. Alright, so now we're going to use the calculator. So my suggestion is, well, obviously you turn it on, and then we're going to press y equals. Then in y equals, I'm going to type in p of x. Okay, and you can kind of see what p of x is there. You do 3, so I'm typing in 3, and then I press x, raised to the third power. Sorry, that's to the fourth power. If we look, p of x is 3x to the fourth power minus 11x to the third power plus 10x minus 4. Okay, so I've typed that in. All I did was I go to y equals and I typed that in. Okay, so now I'm going to press second. Mode, if you notice right above mode is quit, and I'm out of there. But if I went back to y equals, I still have my equation from right there. The p of x equals 3x to the fourth power minus 11x cubed plus 10x minus 4. So I have 3x to the fourth power minus 11x cubed plus 10x minus 4. Okay, so I do press second, quit, get out of that. And now I'm going to go through a series of buttons and I'm going to test. What I'm basically going to do is you can use the calculator to plug in a value for a function much like you would if you did f of x or f of 2 or f of 3. So I'm going to press this button right here. It says vars. I'm going to arrow over to yvars. I hit function. I'm going to press enter there. And if you notice, there's y1, y2, y3, y4. We put our equation into y1. So if you looked, y1 was where we have that equation. Now I have y1 there by doing vars, yvars, function, and then I pick y1. So now I have it twice, so I need to delete one. Okay, then I'm going to do parentheses, and my first number here was -1. So I'm going to test -1. And look, y1 of -1, this ends up being the like if I plugged in -1 to this right here, what the calculator did was it did 3 times -1 to the fourth minus 11 times -1 cubed plus 10 times -1 minus 4. And so what it does is it gives us that function value. So I now know that -1 is in fact a root because it